Hello everyone, and welcome to the history and definition behind recursion. Let's begin. The history. Recursion as an idea emerged outside of the computer science world, obviously long before the first computer was constructed in the 20th century. Richard Dedekind, a German mathematician born in 1831 and died in 1916, first declared the mathematical principles of recursion, or defining a function by induction. Ultimately, he created functions which use themselves in their own definitions. However, the mathematical aspect of recursion and computability was brought together under the work of Kurt Gödel, Alonzo Church, Alan Turing, and Stephen Klein, who of which constructed the Turing machine in the 1930s. There was definitely a recursion aspect to how the Turing machine solves encoded German messages in the war. In the modern era, recursion is defined in Java as methods that essentially call themselves in their own coding blocks. Recursion is recognized today as a rather complicated yet very efficient method for programmers to construct programs with certain needs and specifications. Today, games such as Minesweeper and much more utilize the concept of recursion to simplify code patterning. Definition. Without a doubt, recursion is rather an advanced concept in computer science, though it is essential in certain aspects of program design and efficiency. Recursion in itself has a huge range of applications, primarily in algorithm design. Sort and search methods and algorithms, factorial functions, and even a function to determine whether a word is a palindrome are all examples of how coding problems can be solved through the use of recursion. However, there is certainly one primary key concept in the world of computer science recursion. If all recursive methods return its own method, and that's all they did, then an error would be thrown as system's memory would have been completely used. So far, all recursive methods to work, there needs to be a base case as well as its own method call in the method's code block. To solve problems revolving around the concept of recursion and to produce algorithms which involve recursion, it is oftentimes useful to lay out recursive trees to visualize the process of producing the output. Once the general process and outcome of recursive problems and algorithms have been laid out, it is key to begin the solution process through focusing on the base case. Recursive methods and the base case, as once the base case is activated, usually as a conditional statement, an actual value is returned. Once the bottom value is returned through the base case, other recursive calls change this initial answer until the recursive process is completed. Here's an example of a recursive problem. Obviously, the question is asking what would be printed out to the console. To solve this problem, a recursive tree needs to be laid out. The tree starts at 5, splits to 4 and 3, which splits to 3 and 2 and 2 and 1, and so on. This solution to this problem turned out to be 26, which was seen through a top to bottom layout of the diagram and then bottom to up algebra to find the sums of the recursive problem. Through this method, recursive problems are rather easily solved, which is very, very interesting. Anyway, this does conclude the introductory explanation on recursion, and this concludes the introductory lesson. Thank you so much for listening. Thank you.